Uh, Hello everyone. Welcome to this community call on securing your cloud native applications with Choreo. During this presentation, if you have any questions, please feel free to raise them on YouTube chat. We'll try to answer them as much as possible. I'm Tumula, Senior Software Engineer at WSO2. And before we dive out into our topic for today, I want to loosely define what we think of as a cloud native application. So in the world of cloud native application, one of the key characteristic is to have a set of independently deployed software, each of which is focused on a very specific business function. For example, if you want to develop a property rental system, you could have a separate service handling catalog data, a separate service handling billing, a separate service handling user management, and you would probably have different mobile applications for different mobile OSs and a web application that is running on a browser. And another important characteristic is that these components would talk to each other over a network. It doesn't only have to be a front-end to back-end communication. Even the services themselves can talk between each other. So again, the key thing to notice here is that these communications take place over a network, most of the time, the internet. So our topic for today is securing cloud native applications with Choreo. We'll go through this with a minimal example of a cloud native application where we have one front end and one back end, and the front end communicates with the back end through the internet. And the application that I want to run you through is a simple diary service where you can add and read entries to your personal diary. So again, let me reiterate that in a real business use case, we would have multiple front ends, multiple backend services talking with each other. But for today's session, which is an introductory session on this topic, we'll go with this minimal example, and the learnings that we take from here can be transferred to all those complex scenarios as well. As we just discussed, the components of a cloud native app talks to each other over the network. Our front end would run on a browser, and the back end would be deployed in a server somewhere, and this front end has to talk to the back end over the internet, which means our back end should be accessible over the internet. The problem is the moment you make something accessible over the internet, it's not only accessible to you, but to anyone on the internet. So you need a way to restrict that access because you don't want other people looking at your personal entries in the diary, and you definitely don't want them to tamper with those. So this brings us to the primary security requirement of cloud native apps, protecting services and securely accessing protected services. And also, you'd probably need to open this app up for other people to use as well. But at the same time, you need to make sure that person A cannot tamper with the entries of person B, and person B cannot tamper with the entries of person A. So that means you need to have some information or knowledge about the user that is currently accessing your application and be able to confirm that the user that he or she is claiming to be is actually the correct person. So this is our second requirement, authentication. As you can probably guess, these security requirements are fairly common in any kind of application that runs on the web. And as software engineers, when faced with a recurring problem, we like to come up with patterns and frameworks that solve these recurring problems. OAuth2 is such a framework which somewhat standardized how security is done in this cloud native world. with OAuth2, we pretty much completely solve our problem number one of authorization, and we partially solve the authentication problem as well. So OAuth2 gives a way to pass the user information to your backend, but it doesn't solve the problem of passing the user information to your front end. So that is where this OIDC part or the OpenID Connect part comes in. So OAuth2 together with OpenID Connect can fully solve these two problems of security that we see in the cloud native world. And these OAuth2 and OIDC protocols address a wide range of use cases and very complex, very well-defined protocols. So the objective for today is just to go through a simple use case of these two protocols, not to go into deep details about these protocols. So this flow I have given here is a flow specific to the scenario that we are trying to follow today. So in this diagram, our objective is, so let me just first map. There are some terminologies that might be foreign to you if you are not coming from the from our to OIDC background. So let me first introduce these terms. So the client is the application that consumes another protected resource. And resource server, so in our case, the client would be the web application front end. And resource server is the server that serves a protected resource. So that would be our web application backend. And resource owner would be the person who has the ownership to the resource served by the server. So that would probably be you or any other user of your application. And there's this authorization server, which handles the user authorization part. And we'll get to this authorization server in a minute. But until that, I'll just walk you through the flow. And so our objective here is the client should be able to get permission from the resource owner to access a protected resource that is in the resource server on behalf of the resource owner. So the flow that OAuth2 protocol, in the OAuth2 protocol, the flow we have to follow is we first send an authorization request to the authorization server. So in this request, we say, I am this particular client and I need to access a resource on behalf of the resource owner. So authorization server forwards that request to a resource owner, and then the resource owner has to prove his or her authenticity, and then after proving the authenticity, the resource owner can grant the permission to the client, and the authorization server forwards that permission to the client. So that permission, we call it as a authorization grant. And the client then can go with that authorization grant to the authorization server, and then authorization server validates that this grant is a correct grant that was legitimately obtained, and then it gives something called an access token. So that access token can be used as a key to access a protected resource that is there in the resource server. So the client then presents the access token to the resource server. Resource server validates that this access is a legitimate access token. And if it is a legitimate access token, then it serves a protected resource back to the client. So again, so OAuth2 and OIDC have different protocol flows depending on the grant type that you use, and different grant types as well. So if you are not familiar with those, I urge you to read a little bit more and understand those different grant types as well. But for your information, the grant type that we are using in today's demo would be the authorization code grant. So I mentioned that I'll come back to the authorization server in a minute. So this is where the authorization server part is where an identity provider comes into the picture. So by now you must have noticed that the common theme in this phase is trying to not reinvent the wheel. So as a developer, your time is better spent on writing the actual business logic, which is what distinguishes you from the other vendors out there, rather than trying to solve this recurring problem. So handling the users, managing the user details, managing their logins and logouts, etc., which are related to this security, are recurring problems that have already been solved by multiple different vendors, and those vendors we call identity providers. So almost all identity providers support this OAuth2 and OIDC protocols. So essentially what you can do is you can configure any identity provider that supports OAuth and OAuth2 and OIDC as your authorization server, and you can give it a list of users, uh, add a list of users that you want to allow your application to be allowed to access your application. And then the authorization server, the identity provider in this case, will take care of the rest about how to securely authenticate those users, how to keep their personal information safe, and etc. So, and OAuth2 and OIDC has been around for some time and is widely used, as we mentioned earlier as well. So naturally, there's a good amount of libraries, especially client libraries, that support OAuth2 and OIDC implementation if you are writing a web application. However, still there's a little bit of understanding that is needed from your end in order to use those libraries. Moreover, if your client application is a single page application in particular, so at some point, the access token that we talked previously, which is the key to access a resource, has to be touched by the JavaScript code that is running on your browser. So we have come a long way in terms of making that access all secure. However, we can't say, so the moment your JavaScript code touches something, it slightly becomes vulnerable to some attacks such as cross-site scripting. So this is where we have come up with this Coreo's managed authentication. So this is not something we have like gone ahead and manufactured out of thin air. This is based on the recommendations that are in upcoming recommendations in the OAuth2 community. So this managed authentication behaves as a backend frontend, and it handles your OAuth2 and OIDC flow on behalf of your application. So essentially, this is an independently deployed backend, and that backend performs the OAuth2 and OIDC flow on behalf of your front-end web applications, which means that the access tokens and any other things that needs to be secured does not at any point need to be touched by the JavaScript code. So how we have enabled integrating this to a web application is we have exposed a set of dedicated endpoints to implement a login, logout, and get the user information of the currently logged in user for session management and invoking a backend service. So basically, for example, if you want to integrate a login, what you would do is you would call this /auth/login path relative to your own web application's URL, and then that request would hit the managed authentication of Choreo, and the Choreo will handle the login flow for you. So this would be a bit more clear when we move into the demo. So without a delay, let's start with a demo. Uh, so for the demo, I already have deployed some components in Choreo. I hope you can see the see my Choreo console screen. So I have a front-end component, which is a web application, and a back-end component, which is a service. I have not enabled any security features for these either of these services components just yet. So let's walk through that enabling security part through in this demo. So before we go into the application code, let me just show you around and show you around what we have. So this is our front-end application. So essentially, even though this button says login, we are not really doing a login here. I'm just getting a username as an input and blindly assume that this is the person that is currently using them. And so we have an option to add an entry, and we can get a list of entries. So I do not have any entries at the moment. And so these two, they basically perform a API call to a backend service. Then I can look out. So it's a very simple and a fairly straightforward application. So let me go into the code. On the backend I have written in Ballerina. And so if you're not, again, if you're not aware of Ballerina, it's a language that we develop in-house at WSO2. And if you're interested, you can like give it a try as well. So in the backend service, I have one endpoint to get all the entries of a given user, and I take in the username as a query parameter there, and another endpoint to add an entry, and there I take a JSON payload with a username and a value, which is the value for the entry. And the user's entries I store in a map against a username, and this is an in-memory map. So just keep in mind that whenever we do a redeployment of the application, whatever the data that we have already added for a particular user will get wiped off, and that is expected. Since this is a demo, I haven't implemented a complex logic to like go and store those in a database. And when we move to the front end, in the front end, I have defined two functions which call those two endpoints. This is the get function, and this is the post function which should add an entry. And this API URL, I have added it as a configurable, and in the deployment, I have put that value as a config, and I read this value from the config in my front-end application code. So one more thing about this. So if you have a service deployed in Choreo with public visibility from within any component in that particular, you can invoke that service using this Choreo API's prefix followed by the path of that API, which is what I am using here. So this would be a relative path. So relative to your web applications URL, this would, you can invoke this, and this would hit the service component that you have deployed. And going back, I have defined a function, a wrapper function to get the entries and add new entries. And also, this is my dummy implementation of the login button. Currently, I keep a username value and read it off of this text field and a button for login. And essentially, from the login button, what we currently do is I read the username value, convert it into a JSON string, and set the user info object in the session storage. So in the main application, I have an effect hook that checks whether this user info is set. And if it's set, we consider our user is authenticated. If not, we don't consider the user to be authenticated. So basically, that is the setup that we have at the moment. So the obvious issue with this app is anyone can go in. So as long as they have the application's URL, they can go to that URL, pretend to be you, and add an entry on your behalf, and also get all the entries that you have previously added. So let's try to fix that bit by bit. First, we'll the first step of solving that is to restrict the usage to a set of authorized users so that some random person on the internet cannot go and tamper with the entries of someone else. So how we do that, as I mentioned previously, is with the help of an identity provider. So there are multiple identity providers that you can use for this. And for this demo, I'm using the Choreo's built-in identity provider. However, a small disclaimer. So this Choreo's built-in identity provider is something we have introduced for mainly for testing purposes. So in your development stage of your app, you might not have selected an identity provider yet. So you could use the Choreo's built-in identity provider and try out your flows, deploy your application, and then once you go into production, we recommend you move into a external identity provider that is specialized. So in WSO2, we have a SaaS offering of Astadio, and there are different other identity provider vendors as well that you can choose from. So here, essentially, as I mentioned, now our objective is to restrict this to a set of users that we want to allow to access this application. So let me go to the built-in identity provider and show you what we have. So I have already added a couple of users to this identity provider. And just a note, this identity provider is an organization-wide identity provider. And the users that you add to this would be available to any component within that org. And for each environment, you can configure different set of users. So if I go back to the front-end application and move here, you can see that I have set the Choreo built-in identity provider as the identity provider to be used with this particular component. But if you wish to use a third-party identity provider, you can add the identity provider to your org level. And then from this drop-down, you can select that identity provider as well. So basically now at this point, we have our user base in this IDP. And then our next step is to secure the front-end part and add an actual login that would redirect to the identity provider to authenticate the user. And then we can, from the front end, get the information of the user that is currently authenticated. So let's dive into the code. So before moving into the code, let me just some back up a little bit and mention you that. So what in this case, what we are using to add authentication to the front end is Coreo's managed authentication, as I discussed during the presentation. So since I haven't enabled anything at the moment, I need to go and enable managed authentication first. And there are some configurations that you can play around with. For example, this post login path is the path where after successful login, where the uh, the application should be redirected to. So I have currently set it to the base path. So in this path, you should have the logic to handle the so after login, the Coreo's managed authentication will send you a cookie with the information of the logged in user. So that would be sent to this particular path. So in this path, you should have some logic that would consume that cookie and store it locally. And you have the post logout path. This is the path to be redirected after a logout. So if you have a landing page, you can configure that here. And error path. So if you need to handle errors on your own, you can configure an error path. If not, we will serve the default error path, error pages that we have. And I have configured managed authentication. And when you configure it, there will be an automatic deployment. And the other thing is, as I mentioned, the backends for the managed authentication is provided by Choreo. So when you are developing the application locally, you will not have access to those backends. So your option would be to write some code, deploy to Choreo, and cross your fingers and hope the code you wrote works. If not, you have to repeat that process. So in order to get rid of that friction, we have introduced this local development concept where you can run a proxy and forward the request from your local machine to that backend that is running on Choreo. So let me enable that as well. So this is the uh, command that we need to invoke in order to run the proxy on proxy that forwards the request to Choreo. And let me enable local development as well. So it's enabled. And now let me go to the code. And I need to start up the server locally. Okay, so I have the React server running on port 3000. Now I need to start up the local development proxy as well. So let me paste the command that I have copied. And one other thing that you need to notice here is that you need to replace the port of your application in this command. So we have our application running locally at port 3000 here. So I'm forwarding that value as the port. And so it says you can access your web application on this particular link. And you can see we can access the web application. So let's go into the development and try to add the actual login to our application. So let me go to the login button. So essentially here in the handle login method, which is the on-click function for the login button, we simply need to redirect to the /login relative URL. So this is the only thing that we have to do here. We no longer need this username, etc. because after login, managed authentication will give you a cookie with all the user information, so we can get the username from there. We don't need this. And yes, so with that minimal code change, so we no longer have the username text box. And if we do a login, you can, as you can see, you get directed to a login page, and this login page is the login page served by the Coreo's built-in identity provider. And then we need to make another change. As I mentioned, after a login, we get a cookie with the information of the currently logged in user. So we need to check for that cookie. And if that cookie is there, we need to feed it and keep it stored locally, so that each time the uploads, we don't have to go to Coreo's managed authentication invoke a managed authentication endpoint to check the logged in status. You can do that if you need to do it, but that adds a bit of a delay to your loading time. So any other condition here? So the cookie name is user info. We have this cookie. And the cookie value is a encoded value, which is encoded in base 64. So let me encoded user info, and I get read the value of user info. And then I can decode this using this. I then need to store this value in the session storage. So against the user info, I store this decoded user info. So this is already a JSON string, JSON object. And finally, I can remove this user info cookie. So basically what we do is, if the cookie is there, we read the value, decode the value, keep it stored locally at the browser, and then remove the cookie. So this path will only be hit after login. And after that, we just check if that user info value is there in the session storage. And if it's there, we read it, pass it into a JavaScript object, and then read the username off of it and set the authentication status to true. So let's try this out and see. So this is a user that I have already added to the Choreo built-in IDP. And as you can see, we have logged in, and the username has been read correctly as well. So our front end is now protected with the actual login, which actually authenticates a user. So it is just, it's add a logout to this as well. So with the logout, what we need to do is to redirect to /auth/logout. But one more additional thing to notice here, we need to send the query parameter called session hint. So after login, we set a session, we set a cookie called session hint. And when you are doing a request to /logout, you need to explicitly pass that value of that cookie. This is done to prevent against any CSRF attacks. Session hint, and the value is get session hint. So this should be good. Let's go back and check if logout works. Okay, so login and logout both seem to work as expected. So let's commit this and deploy. So we have committed our code. Let's go into the build section of our web and check the commits. So we now have our new commit here, and let's trigger a new build with this latest changes. And so until that builds, let me walk you through the um, let me walk you through the change that we did. Yeah, I think okay, I undid the commit. So let's forget about that for a moment. Let me walk you through the change that we did. So we import this JS cookie library to handle the cookies. And on our application load, what we need to do is feed this user info cookie. If that cookie is there, we set the user info value in session storage and then remove that cookie. And each time we check whether that user info is there in the session storage. If so, we assume the user is authenticated. And if not, we consider it as a user that is not logged in. And for the login, we simply need to redirect to this OAuth/login. For a logout, we need to direct to OAuth/logout, but with the addition of this for a parameter session hint, because we need to prevent against any CSRF attacks. Oh, let me discard this and get the commit from our string. Okay. Yeah, so we have successfully built, and let's go ahead and deploy this. The deployment is active and application is there. Login. So the login part works, and let's try to add an entry. So you can see the entry is added. So this would invoke a post API call, and then this would invoke a get API call, and you can see the entry is there, and so all well and good. So we can't access the front end now without a login, and then we can log out. Okay, so we have now made some progress. We have given a set of users to which the application is restricted to, and we have protected our front end so that only those authorized users can access the front end. So But still, there's a problem. Now, backend is still exposed to the internet, and we haven't protected the backend. So anyone can still go and add an entry to the backend. So, for example, let's now I haven't. This is a direct API call to the backend, and I'm using the username Ron. So ideally, I should not be able to read the values of Ron. But as you can see, I can see the entry that was added by Ron. So this is clearly not what we want to do. And let me try to add an entry as well. And we can add the entries. And also we have the additionally added entry. So let's try to log in and see what has happened. So as you can see, now when Ron logs back in, the entry that was added by directly invoking the backend is also there. So this obviously this is not something that you own. So the next step is to protect our backend. So how we do that, first of all, is we go to our backend component and click on this endpoint configurations and enable this OAuth2 security script. Let's apply and do a deployment. And now Choreo is protecting your backend from unauthorized access. So if I go ahead and try to do this now, it says unauthorized. Make sure you have provided the correct security credential. So we have enabled the protection from Choreo. Now, the next step is now we need our front end to be able to invoke that application. So what we do is the backend. So we go to the front end component, go to dependencies, connections, and then from there we create a connection from the front end to the backend. So this demo backend is the backend that we have prepared for this particular demo. So we name this front end to backend connection. And so now we have created a connection, and as you can see here also, you're shown with the option of how you can call the backend from a front end, assuming both are deployed on Choreo and the backend is of public visibility. So now if I try to log into the application, and so I have redeployed the backend, and as I mentioned, since I'm using in-memory list of entries, it's expected that old list, all the entries are gone, but you can still see that we can invoke the backend and add a new entry, but someone else without the proper security credentials cannot. So now we have enabled security in the backend and enabled security in the front end. So on the surface now, all things seems to be well and good, but there still is a catch in this setup. So far what we have done is we have defined a set of users at the identity provider, and we have then changed the front end so that only an authorized user is allowed to log in. And then we have changed the back end so that a token obtained by the front end on behalf of one of those authorized users is needed to access the backend. But what we haven't done is preventing one authorized user from tampering with another authorized user's data. For example, now I have now logged in as Ron and I can see Ron's first entry. That is expected. But let me log out and then log in again as Harry this time. So now I'm logged in as Harry, and as expected, I do not have any entries, but the problem is from the front end. So let me just back up a little bit and show you what's actually going underneath here as well. So if you check the network trap, if I do a refresh, what it essentially does is it calls this endpoint with the query parameter username Harry, and so I can still from the browser do a direct call like this as well, and I'm not sure whether this is visible. Yeah, so as you can see, we get a empty list, but we don't get a unauthorized error because with managed authentication, we have our sessions in terms of HTTP only cookies. So in between tabs, they still work without any issue. So now this is expected. Now we have logged in as Harry and we can get the list of entries of Harry. But the problem is if I change this to Ron, I can still get the list of entries of Ron. So this is an unwanted behavior. We don't want people to be able to tamper with each other's entries. So we need to fix this, and how we are going to fix this is, in order to fix this, we need to in the backend to know the context of the currently the user that is currently accessing the backend. So let's go ahead and log out for the moment and let's go to the backend deploy. And under endpoints configurations, if you see, you can see there's option to pass user context to the backend. So in the backend now, as I mentioned, we need this user context in order to make sure do a validation that the user that is currently accessing is actually the person who's sending the request as well. So let me enable this as well, and just if I hover over here, it says the user information is securely sent to the backend as a JWT, and it is embedded within the JWT assertion HTTP head. Let me enable this, apply, and do a deployment on the backend. Okay, so the backend is now being deployed, and in a few seconds it will be deployed. In the meantime, let's go back to the code and change our backend code to read do a validation on the user using that user context that was passed. So let's have a function here that validates the user. So I have a function already written with me. In the interest of time, let me just copy paste that code here, and then I will walk through that function and explain what it does. So yes, so this is the function that we have, and these are currently and as error, I need to import this module. Ballerina JWT. And now it's all good. We don't get that error anymore. And what this function does is it takes in the set of headers and takes in the username to validate against. And then it reads the XJWT assertion header, which is where the user context is passed to the backend. And then it decodes the JWT assertion. And then we check if the sub claim in the JWT assertion is equal to the username that is passed to this method. So this sub is a standard claim in JWT, which indicates a username. So you don't essentially need to rely on this particular claim. So you can rely on a username claim or any other custom claim for this validation as well, or maybe you can do multiple validations as well. It's up to you. For the purpose of this demo, I'm just simply checking the equality of this sub claim to the username. So if those are matching, I consider it a valid request. If not, I consider it an invalid request. So again, what we need to do is we need to change this method to first do this particular validation. So if the user is not valid, we respond with a bad request error and unauthorized error being unauthorized and the description being valid. So this could be could either be a bad request is a 400, or this could even be unauthorized 401 as well. I'm just sending a bad request 400 here just to distinguish between the 401 that is sent by Choreo. If you send a invalid access token. So again, like these implementations, you can we don't provide like we don't have any strongly opinionated way of doing things. So we have given you the ability to customize things as you wish. So essentially, only what we do is we pass you the context in this header. How you do the validation, it's entirely up to you. So need to have this here as well. But here I need to read the username from inventory username, and I'm not currently sending the request. Okay, so I have added this validation to both the methods. Everything looks good. So let me commit this and user validation. Okay, I have committed that. Let's see if we have that commit here. So commits. Yes, we have the universe commit, and let me go ahead and build it. So while that builds, let me just show you what we did. So we read the JWT assertion, decoded it, and we matched the subclaim in the JWT to the username in order to validate the user. So in the request, that request will be getting a username as a query parameter, and also in the header we'll be getting the user context, which is coming from the JWT assertion, which is set by Choreo, and we make sure that both of these are matching so that someone else cannot tamper with another person's data. Let's give it a few more seconds to build. Yeah, so far we can log in as if you log in as Harry, you can invoke the backend API and pretend to be Ron and get Ron's entries. But with this new change, after we deploy the newly built backend service, you can no longer do that, because we in the backend service we validate the user context of the currently accessing user and make sure that we only allow a particular user to access his or her own entries. So let's, as we have already run out of time, let me go back to my presentation and walk you through the final architecture of the demo application. So we are essentially here uh, mapping the architecture to the flow that we discussed in the OAuth2 scenario. So here our client was the web application that is running on the browser along with the Coreo's managed authentication. So this is the part which handle all the OAuth2 related scenarios. We use the Coreo's built-in IDP as the authorization server. But again, a reminder, in a production scenario, we recommend you use external IDP such as SGuardio. And of course, the resource owner is unchanged, that would be used. And the server, we have Coreo's API gateway, which is the part in Coreo which validates the access token. And depending on whether the access token is valid or not, it allows you the communication to the web apps backend service. And from here to here, we pass the user context, and the web backend and validate the user context. And then depending on that, it can give the access to the protected resource. So that's mainly what we wanted to cover in today's session. And if you do have any questions, please feel free to raise those in our Discord channels, and the links will be available in the description of the video. And so thank you very much for joining this today's session.